Now that we've hooked up our H-bridge, let's use it with pulse width modulation. Now in the last lesson, at the last lesson build, we hooked up the enable line to pin 13. That enable line is the one that turns the motor on and off. So we're going to turn it on and off really fast with PWM. However, pin 13 on the Arduino does not have PWM available. So we need to change that connection. I used pin 10 just because I could. You are a highly trained and qualified individual, so you can use any PWM pin you want and just write your code accordingly. So I switched out my one jumper wire from pin 13 to pin 10. The code for this is available in the downloads section. Basically, I just took the code from the last lesson and hacked it to death. Now what I want to do is accelerate the motor to maximum pulse width, then back down to 0 pulse width. I then want to reverse the motor direction using control pins IN1 and IN2 and accelerate the motor, bring it back to 0 again. So we're going to declare a couple of global variables, and I'll be honest with you, I struggled with finding variable names. This is a good lesson to keep an eye out for these things. I wanted to use the word speed as the variable for the pulse width number. But as you can see, it turned that word speed orange. That means it recognizes it as a command, so you can't use that. Whoops. So I wound up using pulse width, and using the typical convention, I capitalized the W in width. I then next wanted to set up the variable for a step through the count. As we count up and down like we did in our fade sketch, we can count up or down by any value we want. I wanted to use the word step, but again, it recognized it. And I forgot. This is for the for command, which is a powerful and very useful instruction we'll get into later on. So I can't use the word step, so I use the word rise, because the number is going to rise by this amount in every loop. I then declared a special kind of variable called a Boolean variable. The variable name is forward, and it's either true or false. It's a Boolean variable. I started it off as true, and we'll get into how to switch it to false later on down in the sketch. I now need to modify the code and set pin 10 as an output. We only want to run these setup lines once to kick things off. Everything else we'll do in the loop statement, in the loop with an if statement. So starting off, pin 12, which is connected to IN1, will be high, and pin 11 will be low, connected to IN2. So in our first run through, we're going to analog write the pulse width to pin 10. So we're sending out a pulse right away. We've also added the rise to the pulse width right away, but that's mostly for when we loop back around, not for the startup. We then check and see if the pulse width is 0. If it is, here's that Boolean variable. Notice to change it from true to false, we have forward equal forward, but with the exclamation mark in front of it. The exclamation mark is a NOT function. You remember our NOT gates. They were simply inverters. They turned a 1 into a 0, or a high into a low, or vice versa, a low into a high. Well, it's the same thing here. So no matter whether our variable is true or false, it flips it to the other value. Now, when we started, forward was true, meaning the motor will turn forward. When the Boolean value forward is false, that means we want to switch the direction of the motor. So we wait until pulse width is 0, that is, the motor is not spinning at all, and then we reverse the direction of the controls. So this forward flag is going to come into play in a second here. Because our countdown is now at 0, we need to reverse the stepping of the PWM. we need to increase the PWM from 0 to 255. So we then do exactly like we did in the fade sketch. We take the rise variable and simply make whatever value it was negative. We just hit 0 on our PWM, so obviously we were counting down. Our rise variable was a -5. We make it a negative of whatever it was, so it is now a +5. And so we'll be adding 5 to our pulse width every time we go through the loop. We then do an if-else check on the forward value. If it's true, then we set pins 12 and 11 to a high and low, or else if it's the false value and it's in reverse, then we set pins 12 and 11 to a low and a high. We then do one last check to make sure that pulse width hasn't gone any bigger than 255. And if it has, then we once again make the value of rise a negative of its value. We then wait a split second before running the loop again. Now, once you get experimenting, you can play with this number and even remove it if you want. You'll see that it's so fast counting up and down that the pulse width isn't repeated enough to actually turn the motor. So making this delay longer will of course allow the motor to take a longer time to accelerate to maximum RPM and then decelerate down to 0 RPM again. Okay, hope all of this is as clear as mud. Type in your code and flash it to your Arduino. If everything is as it should be, your motor should be going faster and slower than stopping and reversing direction.